Hello. Today we are going to discuss about continuous time signal, discrete time signal and digital signal. So let us see what is continuous time signal, discrete time signal and the digital signal. So first, continuous time signal. In this continuous time signal, generally we discuss this signal representation as x of t, where t is the independent variable. So this is nothing but x is the value at an independent variable t. So mostly we take this one as time in our signals and systems. Okay, and this independent variable can be of anything. It may be pressure versus height, or else temperature versus height, whatever it was. Okay, and this height is the independent variable. So pressure is a particular value at a particular height, temperature a particular temperature value at a particular height. So the signal can be any form. Okay, so the continuous time signal x of t, this pressure or temperature, whatever the signal, whatever the value x, takes at every instant of time. So the value is continuous, x is continuous. So this can be represented as like this at t, and this is represented as x of t at each and every value 0. Okay, x as t equal to 0, equal to 0.12, 1.13, 1. Something, 2.56. Not only like this, it can take the integers 3, 6, 100, anything. Okay, t will takes all these values at each and every instant of time continuously. X was defined continuously all the time. Okay, and coming to discrete time signal, the second one, discrete time signal, and this representation as like this, x of n, and this n is again an independent variable which is discrete, like that is n is the values of 0, plus or minus 1, plus or minus 2, plus or minus 3, like this, the discrete values. So not like as a continuous time signal at each and every instant. Here this x is defined at n equal to 0, 1, 2 and all these values, not only the positives, the negative integer values also. Okay, and this is represented as the values like discrete in nature. At n equal to 0, the strength is A. Okay, at n equal to 1, the strength is some B. At n equal to 2, the strength is something C, which is a negative. Okay, at 3, some D, like this. The values are represented like this, minus 1, minus 2, minus 3. So x of n is defined like this. Okay, at each and every instant, not exactly each and every instant, at the discrete values at a particular values of n. Okay, and as the t in continuous time, this n is only 0, 1, 2, 3 as positive and negative. And for example, you can say the rainfall. Okay, rainfall recorded in different years. So the rainfall is like this. So let us, I am taking this R of Y, rainfall, and Y is the years. Okay, in 2000, in 2001, in 2003, sorry 2, like this. So the rainfall is some centimeters, R of Y. Okay, like 100 centimeters, 50 centimeters, and some 150 centimeters, like this. Rainfall is 150, 150 centimeters over the years of 2000, 2001 and 2002. And this years is not represented as 2000.1. okay, 2000.1 years. Okay, else 2001.3 years, and this is false. Okay, you should not represent such signal like this, right? And now coming for this digital signal, let us see what is the digital signal. Digital signal, again I represent this signal as x of n. Okay, so in the discrete signal where we represent the same as x of n, the time was discretized. Okay, one is x of t and x of n. Okay, the t is continuous, but here n is discretized. N was discretized into different set of values, okay, which are integers. Right. But the value of x, it holds the different set of values, okay, for the different n values or different t values. But in the digital signal case, for this x of n, okay, this will be like n is discrete and as well as x is also discrete for the digital signal. Okay, so n is also discrete and x is also discrete. So the discrete in nature means obviously n will be 0, 1, 2, 3, like this. These are the set of values 0, 1, 2, 3, 4, 5 and -1, -2, like this. And the x is also limited to a particular set of values. And you can say in the digital signal, the strength or the amplitude or voltage, whatever the signal, whether it is voltage signal, whether it is a current signal, if you discretized, it will take the values, for example, as -5 volts to +5 volts. It will hold either 0 or -5 or +5, like a pulse. Okay, like a pulse, and like this. Okay, or a signal pulse like this, right? So not like this. You can take the signals as like this, +5 to -5 and 3, it can take a 0 value. So x is also discretized and n is also discretized. So if both are discretized, then such one is an digital signal. Okay, so how we generate this continuous time signal and discrete time signal? The continuous time signal x of t, if you sample this signal, okay, at regular intervals of time, like this, I take a switch and I close the switch at a regular intervals of time, okay, and that interval time is Ts, that is NTS, that is I am closing that one for Ts, 2Ts, 3Ts, like this. So if the signal is like this, so I am closing this one with a switch, and this will be like at 0, at 0, this is x of t and this is x of n, continuous time, and I am getting x of n, your discrete time. At this instant and at Ts, okay, the value will be like this, Ts, next 2 Ts, the value will be this one, and next 3 Ts, okay, the value will be like this one. So if you plot this envelope, you will get a signal like this. So at regular intervals of time, I am taking the particular value, I am holding that value, and that gives the discretized, okay, that gives the discretized signal, that is the discrete time signal, okay. Suppose if you convert this one, that is if you convert these strengths, this strength, this strength, this strength, all the strengths by using the quantization, you can go for the discrete signal. I mean, you take a particular threshold level, okay, or different levels, the quantization by taking the number of bits representing to a particular voltage, you can go for the digital signal, that it may be a 1 or it may be a 0 or it may be a certain values. Okay, this is still an analog signal, okay, x of n is still analog, okay, but discrete time. So now A to D converter, A to D converter, we are going for this x of n, it is a digital signal, and like as here t, we say this t as a time, but here we don't say n is a time, it's an instant of time, okay, it's a particular time instant at Ts, at 2 Ts, at 3 Ts, like that, okay. So by this you can get the information regarding what is continuous time, what is discrete time signal, and what is digital signal. So these discrete time and digital signal both are not same, okay, but the axis, I mean the independent variable axis is discretized, it's a discrete time. If the independent variable and the strength axis also, the strength value is also discretized, and it is an digital signal, okay. So I hope there's a clear picture regarding the continuous time, discrete time signals and the digital signals, right. Thank you.